All right, in this review problem, we'll take a look at these statements and determine whether or not they are true or false. First, for every real number, x squared is greater than or equal to 1. That is false. The reason that is false is that if I put in 0, 0 squared is not greater than or equal to 1. So 0 squared is not greater than or equal to 1. Next, there exists an x such that x squared is greater than or equal to 1. That's certainly true because 2 squared is greater than or equal to 1. Next, for all x, x is greater than negative x. That looks tempting, but that's actually false. The reason is because if I take negative 1 is not greater than negative 1. So negative 1 is not greater than plus 1, so that's false. So because r could be, the values of x could be either positive or negative, this one is false. There exists a value of x such that 4x plus 5 is equal to 6. That's true. And the value in question is x is equal to 1/4. So there is a value of x that it's true. For all x that are real numbers, 5x is greater than 4x. That is false. Again, if I plug in negative 1, 5 times negative 1 is not greater than 4 times negative 1. Next one, this one's a little more subtle. There exists an x that's a real number such that absolute value of x plus 1 is equal to x. That's false. And this one, let me draw a picture. The graph of y equals x looks like this. The graph of absolute value of x plus 1, you take the absolute value graph and then shift it up 1. And these two functions do not intersect. The graphs of these two functions do not intersect. And so therefore there can't be a value of x where they're equal. So that's false. There exists an x, real number, such that for every real number y, x plus y is equal to y. That is true if we let x equal to 0. 0 plus y is always equal to y, no matter what the value of y is. So if x is equal to 0, then this equation is always true, no matter what the value of y is. So this is true. Here we're flipping them. For every x in R, there exists a y in R, such that x plus y is equal to y. That's false. If x is equal to 1, then 1 plus y is not equal to y. So to show that this is false, I need one counterexample, and there is a value of x such that this is false for every value of y. And I should put here for completeness for all y. There exists an x such that for all y, x is less than y. That's false. So why is this false? I just need to find a counterexample. So for all, if x, so pick y is equal to x minus 1. So let x be anything for all x. Then the negation, to show a counterexample, I need to produce a value of y that's a counterexample like x minus 1. X is not less than x minus 1, so that's false. This one's true. For all x, there exists a y such that x is less than y. And so this one, to show it's true, we'll pick y is equal to x plus 1. Okay, so that's the truth values of these statements.